First, I want to thank you for joining us this afternoon to talk about moving to higher asset performance maintenance with industrial IoT. And just give you a quick review of the agenda. I'm going to give a little bit of an introduction, probably take less than 10 minutes, kind of set the stage a little bit. And then we're going to have 3 speakers talk about their applications. These are like case story type discussions. Each one of those will be 20 minutes apiece. And then at the end, when they're done, we'll have a Q&A panel discussion. So I kind of ask you all to think of questions as they're speaking. If you got a piece of paper, some of you would, based on the previous presentation, some of the baby boomers will use paper, the millennials who use their smartphone device or something like that. Write the question down, text it in, or whatever you want to do, so you remember the questions, your questions during the Q&A period. We expect a robust Q&A period afterwards. Okay. So to kind of set the stage a little bit, I'm not going to go through the details of this maintenance maturity curve. It starts off in the bottom with reactive, preventative, predictive, and prescriptive. The main thing I want to mention here is our definition of the difference between predictive and prescriptive. So predictive is usually simplified, single variate. Usually it's vibration. So you have a system that's monitoring vibration, and when there are issues with vibration, some kind of alert goes to a maintenance person to do an inspection or something like that. Prescriptive is multivariable, where you may have some algorithm or maybe using machine learning where you're involving multiple variables, multiple I/O points, a calculation that then drives an alert. All right? And it's our belief that with prescriptive we can reach nirvana eventually and get to near zero anyway, unplanned downtime. So now I want to drill into this a little bit, and this is where are we right now? So this is a survey done about 11 months ago. 141 users replied. So ARC does a couple of types of research. This is a representative of our user research. And there was a bunch of questions, obviously, in the survey, and one of them was, what % of your work orders apply to which category? And in terms of where we are now, for preventative, I included both regular preventative and inspections. So we're near the bottom. There's still an awful lot of reactive going on as average. Your results may be a little bit different. 30% preventative, 10% predictive. So I'm going to drill in now. This gets a little bit technical. And the point of this slide is really to talk about why preventative is going to be problematic, or is problematic. And it has to do with various reliability studies that have been done over the decade. You'll see the first one is UAL, that's United Airlines. Bromberg is a guy who worked for an airline parts manufacturer in Europe, 1973. The US Navy, 82, was ships that float. And then the next one was done also by the US Navy for ships below the water, submarines, all right? And then we just see an average. Of course, these were all done a while ago. Right now, there's much higher adoption of electronics and software, which have random failure patterns. So I expect the results would, if done today, would be a bit more acute, but we'll go with this data. It says that on average, age-related failures are only 18% of your assets. Now, I'll point out the reason you do preventative is that you will do that preventative just before the failure rate goes up. So that's the timing. And that's the correct application of preventative maintenance. Well, this says that that's only appropriate for 18% of your assets. What are you going to do for the other 82% of your assets? You need a different maintenance plan. And it isn't reactive, wait until it fails. And we would propose that this is where IoT and analytics apply. So you can monitor the health of 82% of your assets, and when things aren't going well, when the asset gets sick, do maintenance when it's needed to prevent a failure for 82% of your assets. Okay, so this is a slide is meant to kind of profile, model IoT, because I've seen a lot of things that get, how do I say this, really technical and obtuse and stuff like that. And in my mind, this is pretty simple stuff, and I'll use a model of the cell phone. Your smartphone has in it GPS, it's got accelerometers so you can measure vibration and stuff like that. It also has temperature, monitors the temperature of the processor to see if it's overheating. And there could be other I/O in there. And typically what happens is that data is communicated up to an application on the cloud, and the cloud does some calculations, sends information to your phone, and basically tells you where you are on the face of the earth, in a map. That's how that works. And industrial Internet of Things is not really all that different. You've got a substitute for the phone, your equipment, you send data up to an application or cloud, some analytics occur in the cloud, and it sends an alert to someone who, if things are going bad, would do something about it, all right? And the key benefits have to do with predictive maintenance. Right now, the application for industrial IoT that has crossed the chasm is getting good traction, adoption, depending on the industry, some more than others. Has to do with doing predictive maintenance. And the benefits are increased uptime, increased asset longevity. Uptime helps out with the P&L statement. Asset longevity helps out with the balance sheet, which both get C-suite attention. So that's why they're top metrics for maintenance. And then the third one, cost control, visibility, helps out the maintenance manager. And it ties into those kinds of benefits for the business and the maintenance manager. Now, I'll just point out that before industrial IoT, inspections, for the most part, were done with paper. And you didn't do them very often because they were expensive to do. And when you do use paper, your data quality is pretty low. So with the old way of doing it, your data quality was low and your volume was low because you're doing inspections. With industrial IoT, because it's automatic, your data quality goes way up, the cost of doing one is way down, so your data volume, you could do an inspection every 15 minutes if you wanted to. And as a result, you get very high data quality, very high data volume, i.e. big data, which can be put into some sophisticated analytics if you wanted to, even machine learning and stuff like that. So you get to potential for much higher asset uptime and asset reliability with this higher volume and higher quality of data. Hence the nirvana of nearly no unplanned downtime. All right, now I just want to take this one more step. And this is a nuance with industrial IoT that impacts asset performance management. In the past, some of you are going to, in the audience is going to say, Ralph, we've been doing big data for well, at least 3 decades that I know of, and it's been on top of the historian. And in the way that worked is the historian would get its data from the control system. So it tended to be limited to, not technically, but just the way it was used, process data. So it's things about the temperature, pressure of the process, the fluid or materials being processed. With industrial IoT, now you can start pulling in equipment data. So to use an example, if there are controls engineers in the room, please don't call me on this being a poor example, but it's simplified enough so that I can explain it at least. Let's say you got a pump pushing fluid through a process, through pipe. When the temperature of the fluid is high, you can expect viscosity to be low, and that means that the current drawn by the pump, by the motor driving the pump, would be low. And then when the temperature of the fluid was low, you expect high viscosity, and then the pump would have to draw more current to push it through the pipe. So you got a relationship between temperature and current, temperature being the process data, current being the equipment data coming through IoT. And the combination of those, you can imagine, starts to allow for more sophisticated analytics, multivariable kind of analytics. When those two things got out of sync, it may be a reason to issue a work order for an inspection to take a look at what's going on. Maybe there's a problem type of thing. And this gets to higher levels of asset performance management, this combining of process data with equipment data with industrial IoT.